All right, so as we begin, we're now hitting where we are going to transition. So your new assignments are going to be, with the exception of some of the items this week, you're going to be in Python now. So we need to go over a couple of things. We're going to go through how to install Python one last time, so hopefully everybody has a copy of that installed. It's fairly simple. Again, it'll run on about everything. And we're going to look at what some of this environment we're going to be in looks like, what this idle environment is, what it looks like, why it's important. For those of you that are on Macs, we're going to run into one issue that you're going to see, in that we need to make sure your files have an extension. One of the great difficulties that we have in Blackboard is if it doesn't have an extension, Blackboard's editor can't open it, and I have to go in and manually add it, download them, and make it just adds a little layer of complexity. Macs, by default, don't put on an extension. They just assume that you know what that file is. PCs are a little dumber if you want to look at it the other way, and they need that file extension to say it's a TXT file or it's a doc file for a Word doc. Well, the extension for Python files is .py. So one of the things you're also going to need this week is we're going to actually need the book. So if you haven't, for some reason, gotten the Python book yet, you need the book like today. Okay. Not looking at anybody in particular. I'm just saying you will need the book as soon as possible. So I'm going to run through again that installation procedure. So python.org, and you'll see we're going to send you there quite a bit. So the easiest way, and notice they're up to version 3.8.1. So the 3 is the major version, 8 is the minor, and then the 1 is telling us kind of where we're at on that. So 3.8.1, that's the latest. Any of the 3.x versions would work. So if you happen to be running on Windows XP still for whatever reason, and you can't get anything past, I think it's 3.5, will no longer run on Windows XP. You can run 3.2, 3.3, 3.4. For what we're doing, they're all fine. There is some advantage to running the latest, and there's also some disadvantage. But if I just click here and it says Python 3.8.1, so here we can see some more information about it, and we can see where all the information is stored. So we can actually download then, or we can go up here to Downloads. And here it says, it already detects you're on Windows. It'll do a little bit of browser checking and says, hey, I think you're on Windows. This is the version you need. So I'm going to download it really quickly. And it should take less than a minute to download. It's a fairly small download. And unless you have dial-up, in which case it might take a little bit longer. I'm just doing another video of it. Hopefully somebody will actually watch that. So we're just going to go through, and I've installed this multiple times. So now mine's going to look a little different because I've ran through this before, but really you just need the default, and I'm going to install this, and so now I have Python 3.8.1. Again, it doesn't really matter. The Mac versions are going to look slightly different than the Windows versions. Well, now I've got this, and I know my screen doesn't record down here, so I'm hitting the Windows button to see what's in here. And if I scroll all the way down, you can find Python. Make sure I get it up in where you guys can see it. So notice this one actually has, I've got 3.6, 3.7, 3.8. They'll all install side by side, which is kind of kludgy that they do that, but it's also handy if I want to check my code to see if my code will run on version 3.6. I actually have the environment for it here. So in there, you'll notice that there's several different files, including some manuals, but the thing that we're going to mostly use in here is this IDLE, idle. It's an integrated development environment. And so I'm going to use that, and so I can either click here, and it will open up probably in the other window to make others. It opened up here, good. Or I can just type IDLE in Windows, and it'll pop up. And it doesn't look like it does a whole lot, and in fact, it really doesn't. This is just my shell that I'm putting my command line and codes in. So in our book, if you look at the very first page of the book, so chapter 1, where we start on page 1, and you might want to read the preface. So we talk about what Python is, what does it do, why is it a good language. So we're going to look at some programs and look at Python. So Python's a fairly new language. It's about 30 years old, which I know doesn't seem new if you're 19 years old, but in terms...
You have to realize, like, 30 years compared to like 2,000 years of history.
Correct. 30 years to 2,000 years of history. And if we look back, we're now getting close to 80, 90 years of programming code. And there were certainly some devices before that, but really World War II marked where our programming languages started to evolve, and we started to get moving from mechanical to electronic devices, and we started spending a lot of effort on there and trying to get through there. So page 3 talks about Python and what it is. There is a lot of references to the world's greatest movie troupe. That is Monty Python. And so if you haven't read Monty Python or watched any of the Monty Pythons, well, you may need to know some of that information as we go through here. Greatest set of movies ever. And some of you are groaning. Some of the jokes don't hold up as well over time, but it really was some groundbreaking comedy. So what is good about Python? So the first thing we run into, it says Python's easy to use. And you're going to see that Python is easy to use. We've already showed you a couple of programs. And when you looked at them, you went, wow, that looks a lot like how I would write that. It's English language for the most part. There are some subtleties in our syntax that you're going to run into that will cause you to hiccup. It uses a lot of indents. So indents are your friend. That's how we keep track of where blocks of code are. So it's easy to use. It's really powerful. So there is a lot of things that are great about Python. If I am using a Unix-style operating system, Python is essentially built in. And so I can use it as a scripting language inside of a Linux operating system. If I look at a company like Google, now Google wouldn't tell me what all they used it for, but I have attended some training classes where we had Google employees showing us some interesting tricks and tips and things on Python. So they use it internally for a lot of things. A lot of companies do. That doesn't mean it's limited, so it's not like JavaScript where it's fairly limited in what it can do. It can be very powerful, and so there are large programs written every day in Python or derivatives of Python. So there are a lot of jobs. And in fact, if I go back to my page here, you can even see under, where did they put it this time? I'm trying to remember where it's at. Somewhere, the tab called Jobs. You can actually see some of the companies that are using Python just based on their jobs. So, British Film Institute, there's one. Nexid, Reef Technologies. So there are a lot of jobs out there using Python. So just on this page alone, there's, 20, 30, 40 jobs. Yes, I'd like to go to Zurich, Switzerland and work in Python. So there's a lot of jobs out there. And understanding how Python works, or any programming language, gives you a leg up. If I can get the concepts down with Python, then I can move on to other languages and I can employ those things. Because a lot of the ideas are still the same. That's why I push a lot of this pseudocode and some of this other stuff at you to start with, so you understand that we really only have 3 building blocks. We have the loop, a sequence, and a selection. That's it. That's everything we do is based on those 3 Legos. And so now we're going to show you how to put those Legos together, and then you can go get a job at FAR App, whatever FAR App happens to be. So there are some very large programs that you've heard of. Dropbox is written mostly in Python. So there are some companies that use a Python for a lot of things. So I don't want us to be scared of it. Oops, if I close the wrong one, it would be kind of handy. So make sure you read chapter 1. There's a lot of things in here. We haven't touched a lot on the idea of object-oriented yet, but there's some good parts in here. So page 5 gives you a how to install Python. Again, we've showed that kind of graphically, and it's pretty easy to do. So we're going to jump back into the idle environment here just for a second. So this language works and is pretty handy, and there's things that I know how to do. Almost every language has a print statement. Turn off the caps lock, it'll be helpful. And notice when I type in there, it even changes color, and it says, oh yeah, you're looking for, it must be a key phrase of some sort, and I can print out something. We always say this is going to be the first thing you ever do. You're going to print a hello world. And it turns it green, so anything in quote marks, quotations, it says, you must be special, we're going to put you in green. We're almost, ooh, that water's interesting. Sorry about that. So if I hit enter right now, is this going to work? Anybody want to take a guess? Yes, no? No, some of you are shaking your heads going no. So we worked the last couple of weeks with this idea of methods where we pass information into a method. How do I pass it into a method or a function? What are those key delimiters that say, hey, I'm sending this somewhere else? The parentheses. So my print statement, because it really is a function. In fact, notice when I do this, notice it says, it gives me some information about it. And says, all right, I can end my line, I can do all these kinds of things, and I'm going to put values in. So I'm going to enclose it, and one of the worst things you can do is not end one of these. It's kind of like when you're doing HTML, if you've done that, where you don't put an ending tag in. The computer doesn't know. It's pretty dumb. Doesn't know that you're wanting to stop. So I'm going to hit enter. And now, it put what I typed on the screen. Well, isn't that fantastic? So that's not very exciting, but it says that this code happened to be correct. And I can do that with anything. This portion of idle is called the interactive mode. So I can type in a line, see if it works, but is that very useful for me? No. So I'm going to give you the shortcut of how we're going to make this more useful for our future. So we can do a lot of things in here. I can type help, and notice it will actually, oops, forgot to, it's a void function, so, and it'll actually say I can help on certain things, I can do, but now leaving help and returning back. But what I want to do is I want to be able to write program code, and I want to have more than one line. So I'm actually going to go File, New. And when I do that, notice it looks a little different. It doesn't have this piece on the top. Interesting. And it looks a little different. So I see Shell, Debug, Options. But up here I see File, Edit, Format, Run. So I'm going to type the same program. Print. Now, are we printing to a printer or are we printing to the screen in this case? We're really just printing to the screen. So I'm going to print Hello World version 2. Well, it didn't do anything. Well, that's good. What we're building here with this particular model, so when we're looking at this, now we're able to build some code. So I need to be able to save it. And here's where, for whatever reason, I have a lot of students go wrong. I need to find a place to save these files for when I'm working on them. It may be convenient to store that on a folder I build, or it may be convenient to store them on a flash drive, somewhere where I know where they're stored. We've gotten so used to our phones and other devices just storing things for us, sometimes this is where we get a little confused. So I'm going to click File, Save As up here. And when I do that, it lands in an odd place. So it's trying to save it inside of where the program is actually written. I don't want that. I'm going to click on my documents, and I'm actually going to make a new folder. And I'm going to call this one CMIS 210 Spring 2020. Whatever I want to call it. Now I'm going to open that up and I'm going to save my file. And notice by default it wants to save it as a .py. So .py, it's going to have a strange little symbol on it. I'll show you that here. So I'm going to call this my first program. I'm going to save it. And if I go find that really quickly, documents. This is what it's going to look like. And notice Windows says, oh, it's a .py. It's got this strange little symbol here and actually identifies it as a Python file. Great. We're halfway there. So because it's a Windows file and Windows identifies it, I should be able to just double click it on it and run. Do you guys all see that flash across the screen? It's probably hard if they're recording it. So that program opened, ran, and closed that quickly. Well, that's not as useful as what I want it to be. I usually run my programs. I'm going to close this out so we can see where it's at. I hit the Run button. It's also Shift F5. I'm just going to run module. And now it goes back to that interactive mode, and it runs it down at the bottom here. You see that? Hello World version. Oh, you guys may not be able to see that there. Hello World version 2. And it actually runs it there, and I was down in the bottom, so I just hit a couple enters to drag you back up there. So it runs over in this interactive mode. Here's my program. And then it prints it down here. Let me see if I can make that over. Trying to figure out a way to get that dragged up here so you guys can see that. So there it actually runs inside of there. So this is the typical way I switch back and forth. If I make a change to my code, so, I want to make that 2020, and I click Run, it's going to say I have to change it and save it before I can run it. Because it's actually going out to that file and running it. So I'm going to click OK. It saved it, and now I have Hello World version 2020. So on page 7, they start looking at how do I write my first program. What we need to do is you have to go through this modules in here and work your way through the book. You can't just read it and say, oh, yeah, I understand all of that. Yep. You're going to have to read through there. So they have a couple of terms. They call this script mode. They call this interactive mode. So you'll see the difference in there. This interactive mode is great for trying out something really quickly, but most of the time, even if it's a small program and I want to try something quick, it's really easy just to build it and save it as a program. So there, you'll need to work your way through all the way to the end on page 14. So I will say there is one thing I want to point out really quickly. On page 14, they show a line in a program. And this one's kind of interesting because we're going to use it again. So they use an input. And it doesn't really matter as much what the input is. And they're going to show a couple of things. This way. Now they put in a couple of other items. I'm just going to show you what an input does. This input stops my program and waits for you to put in some kind of input. Now I didn't really pick anything. It's not going anywhere. It's not doing anything other than it halts my program temporarily. And let me show you what this does for me. So I'm going to go File, Save. First program's fine. Yes, I want to replace it. All right. So I went and found my program. Spring 2020. So before, remember, it just flashed on the screen and flashed off. So now, if I use that input to hold that screen open, it's just a trick, the program says, oh, well, now I have to get some kind of input before I proceed on. And so instead of auto-exiting, it holds there and waits for me. So this is in a black screen. So in other words, now I've double-clicked the program to start it instead of running it inside of the idle environment. I don't even have to have idle up and running. I can actually just run this independently then. So there's some good things and some bad things. I just want to show you what that input does, because it seems to, the first time people see that, they go, I don't understand why we're putting that at the end of our programs. But that is one of the very important things that we're going to learn in here. So the other weird thing we're going to learn is how do we put in comment tags? So comment tags are important so that we know what's going on. So different languages. So we've said in pseudocode we use // Well, // didn't change colors for me. Well, maybe I used the wrong ones. No. But notice if I use the # or the hashtag, oh, it changes color. And it changed to red. So I can use this as a comment. It will not run. So comments are really important. So one of the things I like to do to start out the entire year is I create a blank template. So I'm going to say, let me just change this to CMIS 210. Next line, I'm going to put my name in there. And then I might put assignment 37A. So notice those comment tags are going to be important. If you don't have them, your program gets a 0 because I don't know whose program it is. Once we start doing these in Python, I like to grab them in bulk. I kind of need to know who you are. Important part number one. It also lets me know what it is. So I could put a comment tag here and I could say, the line below prints out my information. And I can also use it for one more thing. So I can put all kinds of documentation in there. So I remember what I'm doing. You can also tell me what I'm doing. Those kinds of things. But it does one more thing that I can use it for, and that's that idea of troubleshooting. Maybe I'm getting an error with this line. So I'm going to change this line just a little bit. And if I leave off that parenthesis, this program's not going to run correctly. It's going to come up with some kind of an error, right? But, man, I just keep looking at it. And one of the problems you're going to see in web, in this coding and any coding, is your brain's already ahead of you. And it says, man, I already know what I need to put in there. And when I look at that line, I don't see that it's missing a parenthesis, or you're not missing other punctuation, or you've misspelled something, because your brain is really smart. It fixes what it sees out there. I can use this as a way to troubleshoot. Man, my program crashes every time it runs. What if I do this? And I put that hashtag in front of my line, notice it turns it all red. It no longer runs that line of code. Now I can run my program. Does everything else work? Yeah, must be something in that line of code, and I need to go back then and change it. So it's a really great troubleshooting. Maybe I've also got pieces in there where I put in extra pieces to print out information for me as it's running so I can see how things are doing in a loop or something else. But I don't want the end user to see it. I can then go back in and put those in and say, nope, this is for testing only, and I put in, and I blocked out that line. So that's kind of our shortcut to Python. So if I look at our book, we need to read chapter 1. Not horrible. Pretty short read, but you have to go over and try these. If I'm not comfortable switching between the interactive and the script mode, you're gonna end up suffering a little later on. So spend some time, work through these problems in the book. They really will make it helpful. So page 14 is where we end for this week. So there is an assignment, and this assignment really you have a list of questions. This is the one time that you are not going to turn your program in as a Python file. In this case, you're going to write the code, and then you're going to copy and paste it with your answers into a Word document or a text file. This is the only time you are going to do that in the entire year. And it's simply so you don't have to turn in a .py file and a text file all at one time. So this is the only time we will do that, ever. So there are a set of questions. So the other piece we need to do is we need to finish up our other book, so that online ebook that you have. And we need to finish up with a couple of ideas and thoughts. And we need to discuss this idea of object-oriented. All right. So in your Python book, it actually says, hey, this is object-oriented. And on page 3, it talks a little bit about object-oriented. Well, that one paragraph we're going to expand on a little bit. And so I want to define what I think object-oriented is. It's a buzzword you hear, object-oriented code. So let's dig in. So object-oriented. All right. I think of it as, we looked at those idea of those modules. We're just expanding that idea, that module. So no matter what data we send into that module, it outputs the correct data. So, and essentially we're creating black boxes. We send in data, something correct comes out of that module. We don't care once we've created the module and it works fine, we don't care about it anymore. So we've created this paradigm where we're going to create code and it's going to do things. It still uses the same structure. So sequence loop, it still does everything else except we need to think about what an object is. And this really fits a lot of our models of programming. We have things that can fit this. So an object is really one example of something called a class. So if I think about this in a hierarchy, class, very large, an object is an example of them. So if I think of a class being class called human, everybody in here is human, I think. Is anybody not human? Michael. Nice, Michael. Extraterrestrial. Nice. Can you make your finger glow like an ET? Okay, you're working on that? All right. All right. So we have a class called human. So every human has some common properties. We all do. I would say it's having hair, but I don't fit that one. So, but those things that are common with all of us. So what kind of things are common among all people? Feelings. People have feelings. Do people generally have arms? Legs? We're either male or female, so we have some of these characteristics. Yeah. So a group of objects that all have some common properties. Okay. So we have a definition of it, and then we have an instance. So let's think about a class here on campus. Let's think class people on our campus. You guys all have some common things. And for us as a campus, I like the idea of feelings, but we're a college. Do we care about your feelings? No. No, we don't care. But we do care about some things. What do we care about? Money? No. If we weren't a cheap college, if we were, what college can we pick on? If we were Creighton, we'd probably care more about that. But let's think about what things do we care about. So do we have a way we can identify you with something like a identifying code? In UID, we actually do use your Social Security if you're doing financial aid. We know your hometown. We know characteristics about you. So we have all those things that are in there. So that's a class. So we can create, in our database over there, we can create a class called people or human or whatever it is we want to call it. And they've all got very similar characteristics. So here they use the example of a dog. So here is a dog, and every dog has a name, age, breed, shot status. In addition to that, we can put methods. So we said methods were modules before that were subroutines that did something. Well, now we're calling it a module that says running method and eating method. So are there other methods? What other things can dogs do? Sniffing method, yeah. The pooping method, right? So there's all different kinds of things dogs can do. So the instances then, so an example of that then is we have Ginger, Bowser, and Spot. And so we have their name, their age, what their breed is, and their shot status. So notice we have all three of those items in there. They're very different types of dogs. We have a Boxer, a Labrador, and a Dalmatian. We can say that those are very different types of dogs, but they all have the same common characteristics. They all eat, they all run. So there are some odd terms, and we're going to run into this when we start working in Python. So I want to see them so we can look at it again. When we create one, so instantiating, we call an object. When we make it, we call it instantiating an object. All right. So when I ran my code and I created that class dog and I made Ginger, that's when that Ginger became something that's alive. So the one I always think about is, you guys all remember the first, the Space Invaders where all the little aliens were up in rows across there? So I have class, Space Invader, and then each one of those is an example of a Space Invader. They all have very similar characteristics. And I run them. And in fact, that's one of the first uses of this idea of object-oriented was in programs, where we define those kinds of things. So we define a class, so we have to come up with what does it have. So it's got a name, and it usually has some kind of data, and usually has some kind of a method. So if I am at Peru and I've defined the class human, there are things that we can do. I know that you're going to have a name. I know that you're going to have a birth date, a social security number, and an UID. And I know that there might be methods you also have. So a method might be enrolling class. It's something you do. So a method is really a verb. So I'm going to do something. So we're not hopefully losing you here yet. So here we have this idea of a class for employee. So we have employees here at Peru. And here we have, so in that class, you have information. You have a name and a pay rate. Important things if you're an employee. And then you have some methods. So when we say void, when we set one as a void, all that really means is it's not going to return anything. It doesn't send anything back. So here we have a method called setName, setPayRate, getName, and getPayRate. So we have a list of methods that are going to do something. Those returns, if it has a variable after it, so notice the third one, string getName, returns name back out to the main function that calls it. The return pay rate passes that back out to the main function or wherever it's being called from. So if it's got a return and it has something on back of it, that means, hey, we're going to take that and we're going to shove it somewhere else. You can actually have the same name. Why that's confusing is, even if it's the same name and I use it from a method and the main line, they can't see each other. They're really two separate variables if I do that. So I like to change my variable name just because it makes sense to me, because otherwise I get confused. But in this case, they've used the same name, so get pay rate and they're returning pay rate. The program that calls that doesn't care. You could pass it into any variable name there. X, Y, Z, pay rate, pay rate. I like to kind of name them since most of our code we can self-document. So I would name this one, if I were doing it, get pay rate. Okay, we'll get a number in, and I might say return pay rate from function or something like that, just so I know what it is. Nothing says you have to do that. There are millions of lines of code out there that aren't doing that. So when I declare a class, like what we just saw there, that doesn't make, if I can go backwards, that doesn't make an employee immediately. So I actually have to instantiate or make an employee. So here's an example of that uses it. So it says, here's my declaration, my assistant dot set name. So you're going to see we're going to use that dot notation a lot. So we're going to call this function called my assistant dot set name. So dot set pay rate. So in other words, we're calling those methods to make that work. So that'll make more sense, I think, when we actually do it in Python. But I want to kind of get you over the hump of how this is going to work. So the other thing that's kind of interesting is when we have these classes, just like we had in methods, we could set some of that public. We could use a global variable. Well, we can also do that with our employees and some of their items in there. We can set public and private access to pieces of that information. So think about an employee. Do you want your Social Security number public? Probably not. If you guys do, you can just email that to me and I'll make it public on a forum somewhere. So the methods are going to have either public or private access. So let me look at an example, because sometimes that's... So here we have our employee, and we have fields, and we set the fields private for name and pay rate. Well, that makes sense. We don't want anything outside of this program itself or the functions we're calling to be able to utilize that. So we've set name, pay rate private, but how we set some of this other information, we use public methods. So we're going to get some of that information, but we're not going to release it outside of that particular item. So public and private access, well, that's a little esoteric, and we actually can't, but we're not going to. So if I'm going to send data in, I can use a public function. So that's what we set it up for. But our data then stays private. So here's probably a little better example. So here's some methods. So this is an entire class of employees. So now we've added some additional information. So up at the top, we now have weekly pay. Methods, then we have set name. We have public set pay rate. So the program can send an employee and send that data in. So down below, though, notice we get closer to the bottom. we have one called private. And that just calculates your weekly pay. Well, we don't want everybody to see your weekly pay. So that private pay, that calculation, is only available in this method, in that class. So it doesn't go program-wide. It's only available inside of this particular class. The same way with here we have one, we have a public one below it, says get weekly pay, and so that will then grab it and return it back out. So we have to think about what we're going to do public and private. Again, it's probably a little easier to think about these once we actually start coding them. But I want you to see what the idea of this object-oriented piece is before we get too far in there. So the other thing that's really handy about classes is I can inherit information, methods, data, whatever, from one class to another. Well, all right, that doesn't make any sense. Why would I want to do that? Think about here at Peru where we have class people. Do we have two different classes of people on our campus, though? Would students and faculty have a lot of the same characteristics, but there are some differences? So inheritance lets us create what we call a superclass called employee or called person, and then we can inherit down those things like social security number, hair color, do you have hair, whatever it is, from one to the other. So here we have class salesperson. So if I think about I break my group down into salespeople, they inherit from employee only those fields. It doesn't mean I have to inherit all of them even. But we can limit to what you do. So here's where it gets a little confusing. Depending on where you're looking at it, sometimes we call it a base class, sometimes we call it a super class, parent class, and then you might call what it inherits in as a child class or a subclass. So you can also then chain those together. So you could have, if you wanted to think about it, a grandfather, father, son, where you inherit pieces from each one of them. So it can get a little confusing that way. But it's got a lot of advantages. I don't have to rewrite everything if I know that I have a group of people, even though they may be in subclasses. So maybe we have the subclass of students. Are there different types of students then? So we could break ours into...
Get the answer to that on Apple Watch.
Thank you, Apple Watch. So I could break it into then by school. So you could say person, student, School of Arts and Science. See how we could break those down and they can inherit all those characteristics of that. So big word of the day, polymorphism. So polymorphism really means that we can create code and it can take in about any kind of data and output it in the right form. So we take data in and it says, oh, that's text. I'll fix it and output something. And it outputs it correctly. So when we think polymorphism, I really do think black box. I've created a module that can handle all different kinds of data. And it outputs it correctly. So I've created a very robust, very reliable module, and it takes in data. So whether it's date of birth and it says, oh yeah, I recognize that as date of birth, and I put it in, or you put in a name and it says, oh, that looks like a name, and I can deal with that. So we try to write as cleanly as we can so we can use that idea of polymorphism. So we know the pay is different for part-time employees versus full-time, but if I send that data into my program code, it should be able to understand those differences, and I don't have to tell it every time, this employee is part-time. It can look at the payroll clock and say that works. The other term you're going to see is something called encapsulation. And we've used that before. That's we're just wrapping data up. So this is that idea that I can't see data from a method to my main program, or from different main programs all running at the same time. So I could actually run multiple versions of Python on my program or on my computer. If I have a program running, it can't see what's in another program. They're encapsulated. They're set apart. So we use this as a way that we keep this data separate. So there's an example of encapsulation here. So passes employee data to and from methods, but I can't see it from the mainline program. And that's really good. I don't want one of my programmers to be able to add an extra line of code in the mainline program that we can now go out and access information that's not in our code. Yes, sir. We actually will do that at some point and fairly quickly. But think about our main line as that stuff between the start and the stop. And then all these other pieces we're going to add in as things we're going to reference to. They're subcode or other pieces of code we're going to run. And I want each one of those to be separate. If it's in that main line and I put a variable in there, I can see it all the way through that main code, all the way from start to stop. But if I have it in a subroutine, that's when I have to send data into it and pull data back out. In other words, I can't see it directly. And we do that. It makes things like a lot cleaner and keeps us from doing dumb things like having our Social Security number available anywhere in that program code. So there's a lot of advantages and a lot of disadvantages to object-oriented code. It takes a little more to set up in some cases. We have to think about how we're going to break things into classes or groups. We can't just sit down and start writing out and banging out 10,000 lines of code. Because if we don't plan ahead, we're going to be in a little bit of trouble in there with this. So once we start doing them, you're going to see that they're kind of like real-world objects you're going to see. So we have used this idea for a long time. If you wrote video games back in the 1990s, we actually had a term called a sprite. You guys ever heard of a sprite? It was, you have? Not the drink, but yeah. Scratch still, yeah. So that sprite really is an object. Each one of them is an instance of an object. And so we could program those characters. So think about those video games you play. And all of you play video games except Nancy, right? Nancy says, I don't play any video games. So maybe we should have video game playing in 101. But if you think about a video game and each character that you encounter really is an object. It's got its own abilities. Even though we created it with the same characteristics, they can each do things independently. So that's what we're really looking about is how do we model things into groups? So we typically look at real-world examples. How do people model? How do we look at those? So object-oriented is really making sets of blobs, as I like to think about it. You have a blob here for people. You've got a blob here for work sites. You may have a blob here for projects I'm involved. And we can pass data and information in and out of those blobs, and we can be very abstract then with our code. Our code says, hey, I need Space Invaders to march down one line. I don't have to write the code then for each individual Space Invader. I wrote a code that passes into that whole class and allows that class to start functioning. Then we have the special ones that dive off and do other things. So they're a subclass. So we might call those the dive and kill methods or whatever we are. So we can start breaking those down. It makes a lot more sense. Make sure you read and understand it. And we'll finish up some talking about it on Thursday. But once we start doing them in a couple weeks in Python, then it'll start to make a lot more sense to you. All right, so this week, let's talk about our assignments real quick, and then we'll work on them also on Thursday. If I can find the right button here. So this week, you have a whole litany of assignments. Oh, I know, it's terrible. So the first thing we're going to do, You need to make sure you've got Python installed. If you don't, you can't do the assignment, and it gets a little tougher from there. So you have an assignment. It actually has 5 questions. Make sure you read the questions carefully, especially number 5. Make sure you send one file, either a text file, Word document. Again, if you're on a Mac, make sure you put in that file extension. If you're going to use Google Docs to try to do this, make sure you save it as a file that I can open, not a link to Google Docs. I've had some people in, not necessarily this class, but other ones try to send me Google links to Docs. Works really well. And you actually have said, hey, anybody in the admin.campus.peru, whatever link, can open it, except your faculty aren't on that group because we don't have Google Docs accounts. So if you're going to send it in Google Docs, use that Save As feature. Save it down as a doc or as a Excel file or whatever it is you're looking at. So just kind of a hint there. So you're going to turn in one file. You have some questions to answer. You do have a quiz, and we'll finish up talking about object-oriented code. So this is actually the last quiz until the final. Oh. So that's good and bad depending on how you think about it. So we are going to have a discussion board every week from now on in place of the quiz. Yeah. But let me show you what the discussion boards start looking like. So the discussion boards, so there is actually a discussion board this week. So you have to go to python.org, and there's a question there. You'll notice then you have a discussion board for next week, for week 8, week 9, and week 10. So these are all the ones where you're starting to find your things like resources. So they're designed to be helpful and useful. Once we hit week 11, once we reach 11, you're going to see that what you're actually doing is posting your code and then constructively helping the rest of the class. So once we reach week 11, if you, for some reason, decide not to do the homework, the bad side is you're kind of doubly penalized for that because there's 2 assignments based on that homework. Both creating and doing it on your own, and then also assisting with others and how they struggled or how we can help them get that project done. So I think it's important to look at everybody else's code and look at other code examples. It'll show you ways we can do things. So that's your assignment this week. There is, like I said again, you need to make sure you've got Python installed. If you have problems installing it, now is the time to contact me, not 6 weeks from now. So if you email me on week 16 and go, I just could never get Python installed and I never did any of the programs, I'm probably going to give you a harsh message and dose of reality that says, please come back again next spring and take the class again. We don't want that. We don't want that. I hate putting F's in that final grade sheet because it makes me actually go back and do 2 things. If I put in a grade, I actually have to put in some other information. If I put A through D's, I don't have to put in extra information. And I don't really like D's either. So I like A through C's. And everybody in here taking the class can pass. I know you can. And in some ways it's easier, I think, once you start running the code. Once you're able to run it and you can see, hey, does this work, does it not work, then I think it becomes a little easier to deal with. All right. Everybody got the idea what the assignment is? All right. So we're going to finish up on Thursday talking about object-oriented coding. We're going to go over last week's homework assignment and what some possible solutions are and what other people have come up with. It was not designed, so I threw a lot of material out there trying to help you get there, and the idea of modules, those subroutines, seems to be a sticking point. So I'll show you what we looked at. And again, once you do that and you see it live when you're working with that code, maybe that becomes easier for some people. All right, any questions before I cancel the video recording? Going 3, 2, 4, 7, 19. All right. See you guys on Thursday.